Hi everyone, back again with some law of sines and cosines. Um, this may be something that you saw in geometry, but I'm not sure if it's something that you do cover. But all the stuff that we were just working with on the special right triangles and SOHCAHTOA, I forgot to mention those are only specific to right triangles. So what happens if we don't have a right triangle? Well, this is where law of sines and cosines come in. So if we don't have a right triangle, we still want to be able to solve the triangles, right? So law of sines says any of these ratios can be true, okay? So I used little or lowercase lettering for each of the sides, and then angles are usually always capital letters. So for example, that's saying that the ratio of this side A over sine of angle A should be equal to the same ratio of side B over its sine of angle B, okay? Which should also be equal to side C over the sine of its angle C. So any one of those you can match up and say, okay, we're going to set these two ratios equal and solve for any part of the unknown. The converse is also true as far as like sine of A, sine of angle A over side A. So it doesn't matter what order you put them in. It just kind of depends on the type of problem that you're working with. And I'll explain that a little bit more when I go to the examples page. So this is just trying to fill in the note sheets that you have. So you can print those copies off, or if you really want to go get the copies at the school, they're in the main office. You just ask for the Honors Algebra 2 pink packet. There's just 2 pages stapled together. But law of sines can be used to find side or angle measures, usually best if we're given 2 angles and a side, or 2 sides and an angle, but that's the one where you have to be careful, at least in showing angle triangles congruent, right? Because if you use side angle, you are potentially what it spells backwards if you use it. So that's just a way that I remember to not always rely on side angle, okay? So here's what that page looks like. I just want to go through and, like I said, fill out the notes first. So again, using side angle, this is where you have to be careful because it's possible to have one solution, 2 solutions, or no solution, okay? That's why it's called the ambiguous case, and this is the one where we don't really use it for triangle congruence. Okay, the sine function always should have values between -1 and 1. So if you get something outside of that, then that's actually something that doesn't exist. Or if you try to take the sine of 2, for example, that's not going to be something you can do. Okay, the sine is always positive, and the angles lie in quadrants 1 or 2. We'll get to that more later, but what that means is if we're going around the circle and we start with the positive x-axis at 0, that means if I go through quadrants 1 and 2, that's where sine is positive. So that's angle measures from 0 up to 180 degrees. Okay, so those are what we're working with as far as possible angles. So if you get one angle, if it's another possibility, you can subtract from 180 to find its other possibility. The sum of angle measures of a triangle we also know is always 180. Okay, and then in a triangle, if we get something where we have 2 obtuse angles, we know that it can't be a triangle. Okay, so these are again more practices of setting up triangles and trying to use law of sines with them. Again, for each of these, I would make sure that you set up a triangle ABC and then you fill in the missing information. I would label side B, or I'm sorry, angle B as 37, for example, here in number 8. And then you need to make sure you set up your ABCs, and then side AB would be 47, AC 29, and then you have to find angle C. Okay. To fill out the rest of this note page, law of cosines. This is kind of similar to the Pythagorean theorem, and I hope you can kind of see that, right? But it says the law of cosines can be used to find side and angle measures, again, of any triangle. They don't have to be right triangles. And usually it's best if you're given 2 sides and the included angle, or all 3 sides. Okay, so we've got a squared equals b squared plus c squared minus 2bc times cosine a. So this is kind of how I think about law of cosines. If I'm given this triangle, which one of these formulas I use depends on which angle I have. So if I have angle A, I'm going to use this top formula. If I have angle B, I'm going to use the second one, angle C. You get the idea, I hope. Okay, so sometimes one of the unknowns might be one of the other ones. A lot of times, though, we're given the angle measure and then not the side opposite. That's why we're using law of cosines. So again, like I said, I have a note page for you that I'm going to go through. I just kind of wanted to fill in any missing information on this page, but this kind of just has all of your work on it. Okay, let's get to my note page. Okay, awesome. So here's our law of sines and cosines notes and practice. So it has the formulas again at the top that are a little bit tougher to read. But again, we say law of cosines is the best choice if we have all three side lengths, okay? Or if we have two sides and then an enclosed angle is known. So I'm going to walk you through that example. This one is pretty good. If I go through, just plug everything in. A squared equals b squared plus c squared minus 2bc. And then the only thing that I have is times cosine A that I wouldn't know for this case 1. So in all of that, I would plug in my A, B, and C in those places, calculate all this, calculate b squared plus c squared, add that up as a number. Okay, then do minus 2 times b times c. Okay, but you cannot subtract this yet. So I would add b squared plus c squared together, subtract it over to the other side. So then you have some number which is a squared minus b squared plus c squared together. And then you would have it equal to negative 2bc cosine A. Then you could divide by negative 2 times b times c. Okay, then you'll have a number equal to cosine A, and that's where you can do cosine inverse to get angle A. Okay, and I think there's a Khan Academy video that I'm going to attach that has that for you as well. But case 2 is the one I really want to go through because this is where you're probably going to use it a lot. Okay, so we have angle A. We don't have side A. We have sides B and C. Okay, so I'm going to use the one that has cosine A. All right, so I'm going to take 24 squared plus 13 squared minus 2 times b times c times cosine of 87. Okay, the very first thing I would do then is put a square root over the top of that, and you could plug that in your calculator if you have a calculator like we use at school at home and available to you. That'd be awesome. But if you don't, then you have to be careful with order of operations. So I would take 24 squared plus 13 squared, and then minus, you got to make sure this is all multiplied together. So you might want to do this whole thing right here. 2 times 24 times 13, maybe get what that number is, and then find cosine of 87. You're going to take that number times that, okay? So you might want to find this number minus, and then find it as this number, okay? Then we take the square of that whole entire thing, and if you do it correctly, you should get 26.68, okay? If you're using a calculator like we have at school, you need to make sure when you go into mode that it is in degree and not radians. Okay, law of sines. This is where law of sines is best. If you have two sides in an angle opposite, and one of those sides is known, and you're trying to find the other angle, or if you have two angles and one side is known and you're trying to find the missing side. So let's go through this case 3 right here. Excuse me. Okay, so I'm going to set this up. I have this angle and its side opposite. I have this side, but I don't have the angle opposite. So I'm going to set it up with the thing that I do not know in the numerator. I think it just makes it easier that way. You don't have to, but that's how I'm going to set it up for this one. So sine of x is going to be in the numerator right here. Okay, so I have sine of 115 degrees divided by its side opposite, which is 49, equals sine inverse of x, or sorry, not sine inverse yet, we're going to use that to solve, equals sine of x over 16. So the very first thing I would want to do to get sine of x by itself, multiply both sides by 16. okay? Then at that point, I just have sine of x equals this whole entire thing. So I could take sine inverse of this whole entire thing, which is now rewritten right here, and that would be 17.21. Again, it's a lot easier if we have a calculator like at school. If not, you just got to be really careful in your calculations. So I would probably do sine of 115 degrees. Then you could divide by 49 times by 16. And then whatever that number is, take the sine inverse of it. And you should get to 17.21. Again, mode degree. Okay. Case 4. So I have this angle, and I have an unknown side, and then I have this angle and a known side. So this is one part of the ratio that we can set up. But if I already have two angles in the triangle, I can find this other angle opposite my side unknown because I need that. So this time we have a side that's unknown. I'm going to put that in the numerator over sine of 110, its angle opposite, equals side 15 over sine of 22. Okay. To solve for x, I'm just going to multiply both sides by sine of 110. So how I could plug it in the calculator, if you have one like we have at school, take 15 times sine of 110 over sine of 22. Okay, otherwise be very careful if you're plugging it in a phone calculator. What we should get, oh, this shouldn't be degrees. I don't know why I put a degree symbol there. It should be units. 37.63 units. This is not an angle, it is a side length. Okay. In general, you can kind of see that law of sines might be easier if you understand ratios and proportions a lot more. So I would always probably try to see if that's something you can use first. And that is the end of law of sines and cosines. Again, I'm going to post some more videos from Khan Academy, give you some practice on Delta Math, where if you want to try a couple with feedback first before you just dive in, you're able to do that. Again, if you have questions, please feel free to email me. I wish you luck, and I hope that your family's staying safe and healthy. And I'm thinking of all you guys, and I miss seeing your faces. All right. Until next time.